Greetings, friend. Timberlake here from Smart Hobbies, the channel that helps you transform a passing interest into a fun and enjoyable hobby. Today we're looking at Sudoku. I'm going to solve another hard Sudoku puzzle and show you all my strategies as I do it. Before we begin, don't forget to subscribe to my channel. I like to post new Sudoku puzzles every week. Let's get started. Okay, I'm going to do a random puzzle from Sudoku. Here we go. And I will show all the candidates. Like I've said in the past, if you're going to do a hard puzzle here is equivalent to like a diabolical puzzle that you'd see for pencil and paper. Once you're getting to this level, you'll require advanced strategies. Those are the ones where you'll need to focus on eliminating candidates and not just looking at the solve cells and doing cross-hatching and those types of techniques. So I show all the candidates and pretty easy starting off. You know, we got to make a single 4 here and a 1 here and block 4, and an 8 is a hidden single by itself. 5 6 5 6, so I can get rid of all the 5s and 6s cutting across there because that's going to be a naked pair. 3 7 3 7, that's also another naked pair, meaning this is a 1, that's a 2, and that's a 4. The 7 8 and the 7 8 is another naked pair, gives us a 5 here and a 3 here. It'll give us an 8 and a 6, and row 6 is complete. Looking good so far. We got a lot of the middle taken care of. So now I'm going to kind of focus my attention towards the top here. You'll notice in row 1 there's 1 3 hidden single, so we can solve that, which will give us a 7 and a 3 here and block 6. And then we have a 2 9 2 9 4 hidden single here. And now I'm going to kind of focus my attention again. So we have a 5 9 5 7 9 and 5 7. So that's a naked triple. I can't do any eliminations off of that just yet. So I'm kind of move my way down here. And what I'm going to look for now is just going to scan across, see if there's any other hidden singles. And where you can identify a hidden single would be, you see that there's like a 2 right here, but there's also a 2 right there. Well, since there's 2 of them, that's not a hidden single. And so I'll keep scanning across 5, 6, and 7. So there's multiples in row 3 of all of those, so I can't make any eliminations yet. The other thing you can do is, like, if these 2s are the only 2s here in row 7, then I know I'd have pointing pair, but there are a couple more 2s here. So that's kind of an easy way to scan through that. Got that from Sudoku Swami. Great channel, you should check it out. But it's also a great way to check. So like right here in row 8, this is going to work really well because you can look across. There's 1s, 2s, 3s. There's only 1 3 right there. So that has to be a 3. And then you kind of scan the next groups, 4s, 5s, 6s, okay, 5s, many multiple 5s and 6s, 7s, 9s, and then there's an 8. So we're going to be able to solve this 3 here and this 8 here. And those are hidden singles. 4 6s, 7 9s. Okay, so now we also want to look from the rows and columns that we just solved. So we just solved the 3 here. You're looking up, 2 5 7, that's a naked triple. And then the 8, I have 2 7, 2 5 6 7, and a 5 7. Okay, don't see any other eliminations I can make just yet. So now I'm also going to look for some maybe pointing pairs or claiming pairs that might lead to some further eliminations. I don't see anything jumping out at me just yet. So what I'm going to do now is go and we'll start looking at the candidates. So this shows all the ones. There's no more eliminations there, but by showing these candidates, I can look for X-wings, finned X-wings, swordfish, if that's applicable. Also, you can kind of see some unique rectangles, and then 2-string kites, or called turbofish. So if I see any of those, I'll call them out. And if I happen to miss a naked, or excuse me, a hidden single, they'll easily appear as well. So right here, that's what we're talking about. So you notice with the 2s, there's only 1 2 left on row 8. So that's got to be a hidden single. And then we'll focus over here. No other eliminations we can make. Okay. Let's go to threes. Yep, another hidden single. 3, and the threes are all done. Let's go to the fours. There's a 4, there's a 4. The fours are all done. And yes, if I did paper and pencil, these would be easily identifiable and I could solve them. The point of this puzzle is really to get to the part where we start needing the advanced techniques. Okay. So looking here, what I can already notice, even though I'm on the 5s, we'll go over to the 9s. You'll notice that in block 1, the 9s are locked here in row 3. So that means this can't be a 9. We can eliminate that. And then the same thing in row 2, the 9s are locked here in block 3. So this and this is also not a 9. So the only 9s in block 2 are in row 1. So that's just cleaning it up a little bit. I'll go back to the 5 just so I don't miss anything with the 5s. I feel like there might be something here that I'm overlooking. I don't see it just yet. You're really looking for a lot of like strong weak links because that's how you can make eliminations. This is kind of what they call an empty rectangle. So I could point out here, go to this 5 and come on up. And if there's a strong link to that 5, then we can make an elimination over here, but there's not a strong link. And there's no 2-string kites that I can make either. Okay, 5, 6, 5, 6. All right, so we can make elimination here. This is going to be a unique rectangle. So you notice there's the same pair of Bivalley cells, 5, 6, 5, 6. They're in 2 rows, 2 columns, and 2 blocks. We'll notice down here is that there's a 9 here and a 7 there. And you'll notice that the 5s don't exist anywhere else. Oh, excuse me, the 6s don't exist anywhere else in the column or the rows. So what we can't have, since this is a unique solution puzzle, is we can't have 5, 6, 5, 6, and then solve the puzzle, and you understand 6, 5, 6, 5. So a 9 or a 7 has to be a solution to one of these here. And since 5s can appear in multiple places along this line, we can actually, oh, this is a pretty cool one. So you notice this is actually going to be a virtual triple. So there's going to be a 9 or 7 here, plus a 5 or 6 here, and then there's a 7, 9 right here. So this acts as your, as like a naked pair. So you have a 7, 9 and a 7, 9. So we can eliminate a 7 and a 9 from everywhere else here. Because the 7, 9 is going to be here, or it's going to be in one of these spots. Pretty cool. The other thing we can eliminate is you can go diagonal here, and since 5s can also appear in this row or column, we can eliminate the 5 from there, and we can eliminate the 5 from there. So that's a special type of unique rectangle. I believe that's a type 4, but I'll confirm that and put it in the comments. And so what do we notice here? Anything else with the 6s? 5, 9, 5, 6, 6, 9, 5, 7, 5, 6, 6, 7. Okay, well that's good. I'll get back to that. Let's go to the 7s. And we have ourselves a nice looking X-Wing. All right, let's check out this X-Wing. I'll use the orange for the X-Wing right here. So what it means, in these 2 columns, the 7s appear in exactly the same 2 spots, right? In row 2 and row 8. So 7 has to be here and here, or 7 has to be here or here. It's called an X-wing because it makes a big X. So what we know by that is that we can eliminate all the other 7s across row 2 and row 8. There's none in row 8. In row 2, none of these can be a 7 because we know the 7 has to be here or here. So there, we just cleaned out a lot with that X-wing. Now, let's look and see if there's anything else we can clean out here. I don't see any other eliminations, but that helped us quite a bit, get rid of those 7s. Let's go to the 8s. Okay, 7, 8, 7, 8. There's no 7s here, so this is not a unique rectangle. We can't make eliminations there. And then go to the 9s. We've already made all these, cleared out all these at the top. And I'm looking, yeah, you have some interesting formations here, but I think we've already made the eliminations that we could. So like there's a 2-string kite coming out here at block 9, so there's a strong link there and a strong link there. So wherever these two meet, there couldn't be a 9, but they meet in this cell, and so that doesn't help us. All right, now look at my XY, and you'll see there's quite a lot of, there's all the Bivalley cells, BVCs I call them. There's quite a few here, so I could probably start working towards an XY chain and make eliminations that way. But I think those take a little bit longer. I think I'm going to look and see if I can make any XY wings, because those might prove a little more fruitful. So you can still have the stuff to help with the XY wings, because we're going to be using Bivalley cells to see if we can make some eliminations here. So the other thing I look for are WWings, because those start and end with the same pair of Bivalley cells. So one thing I'll look at is things like the 6, 9, 7, 9, and 6, 7. Okay, well that makes a naked triple, so we already know that that can't be a 7 or a 9. That helps. And so this 1, 5 is a pointing pair, but it's also a naked pair, so that can't be a 5. So now we got the 7, 9, and 7, 9 here. So that was helpful. 5, 7, 2, 7. So now we can look to see if there's a 2, 5 somewhere. Yeah, there is a 2, 5, 5, 7, and 2, 7. So how this works is this is called a bent triple or an XY wing. And I'll just kind of show you. So no matter how you solve it, you solve this for 5, this has to be a 2. You solve this for 7, then this has to be a 2. So a 2 is either here or here. So any cells that these both see, they can't be a 2. So you cannot have a 2 right there. That's called your X, Y wing, because the X and Y are the two candidates, and then it makes kind of a wing. Other people call it bent triple. You can kind of see how it looks bent there. So how does that help us? Well, now we have a 5, 6, a 5, 7. Is there a 6, 7 we can play off of? No. 2, 9, 7, 9. And then I look to see if there's a 2, 7. I don't see that. 5, 9, 5, 7. I look to see if there's, no, there's a 7, 9, 5, 9, 5, 7, and 7, 9. This won't lead to any eliminations because the two 9s here could eliminate from there, or they can eliminate from here, but there's no 9s in there already. So that doesn't help us. All right. So where else do I want to look here? Things to keep in mind. Is I think I could start doing XY chain. I think that will get us close to the end here. So for an XY chain, it's all Bivalley cells. You start in one. So like if I start in this cell, I'd go 9 to the 7. There's a strong link there. And there's going to be a weak link from the 7 to another 7. So 9 to 7, 7 to the 9. Okay. And then you go from this 9, you got to go to another 9. So 9 to the 5, 5 to the 7, because these have, you know, the links. And then this 7, I'm trying to get it back to another 9. So 7 to the 9. Now realize this 9 and this 9, any cells they see can be eliminated. Well, those are already filled in, so that doesn't help us. But then we can go 9 to 2, 2 to 9, and then these wouldn't contain 9, and these wouldn't contain 9. So it doesn't help us again. And if I go down here, 9 to 7, 7 to 6, 6 to 9, well, yeah, there's no other 9s that are possible here. So we kind of, so it was a nice long chain, but it didn't lead to any eliminations. So we need to kind of look to see if we can get elimination out of this. 9 to, let's try it this way, 9 to 7, 7 to the 2, 2 to 9, 9 to the 2, 2 to the 5, 5 to the 7, 7 to the 9. So here and here, nothing. Okay. How about, try here, 7 to 2, 2 to 9, 9 to 2, 2 to 5, 5 to 7. So we already made that elimination. Seven to 9, 9 to 7. Yeah, we already made elimination there and there. 7 to 6. Okay, yeah, I'm not seeing an elimination that we can make out of that. How about 5 to 7? Starting here. 5 to 7, 7 to 2, 2 to 9, 9 to 2, yeah, 2 to 5. So what would happen is that this right here can't be a 5 because this 5 and this 5, any that they both see could be a 5. So you can eliminate the 5 right there, which is helpful. And now we have a 7, 2, 2, 5, 2, 7, and a 5, 7. Cool. Five, 9, 7, 9. Looking for a 5, 7. We don't have that. And then you also have another bent. This does create for us another bent dribble or XY wing. So we have the 7, 5 here, 5, 2, 5, 7, and the 2, 7, right? Well, look right here, 5, 2. So if this was a 5, that has to be a 7. This is a 2, that has to be a 7. So anywhere where they both see can't be a 7. Well, that means we can eliminate the 7 right there. That has to be a 9. That is probably going to crack the puzzle. 7, 6, and these are all just naked singles now. I'll get rid of the shading. You see I'm just falling because they just start eliminating themselves. The 6, the 7, and usually I count this. Ends up being about the last 19 to 20 in a puzzle will be all naked singles. So what you notice there's a pretty cool unique rectangle, a type I don't see very often. And then there's a couple of XY wings that helped us solve this puzzle. Sudoku's been solved. Well, what do you think? Do you like those techniques? Did you have another strategy in mind? Try to solve on your own, see where you got. If that was too easy for you, then I'll put a link to another video where I do a harder diabolical puzzle. If that was a little too hard and you just want to start the basics, I'll put a link to my beginning puzzle, how to solve easy Sudoku. We can go from there. Thank you so much for watching.